Hi everyone, this is Gigi from Kauai Community College. This is a video on basic integration technique. So it's a practice problem after you have already watched the video on basic techniques. Okay, so make sure you have done your learning first from the other videos before you see this one. So here we have the problem of the integral of x minus 2 all divided by x squared plus 6x plus 13. So looking at the denominator, it seems like we could complete the square, right? So x squared plus 6x plus 13. So I'm going to go down that road and complete the square and see where I will be headed, okay? So x squared plus 6x plus 13, and if we see 6x, we would say, well, I wish I have 9, right? Because that will make it a perfect square. So this trinomial right here will make a perfect square. So 13 is 9 plus 4. So that becomes x plus 3 squared plus 4. So that would change my denominator now to a perfect square plus 4. Now, so if I do a u substitution, the denominator is a quadratic, so that du is going to be a linear term. Okay, so that's my thought process there. So I think I'm going to try to let u be x squared, x plus 3 squared plus 4, the whole entire denominator there, right? And the whole entire denominator is x squared plus 6x plus 13. It's just written differently. So du would be the derivative of that, which would be 2x plus 6 dx. But wait a minute. I don't have 2x plus 6. I have x plus 2. So how am I going to relate x plus 2 to 2x plus 6? Cleverly, I would say, x plus 2 is 1/2 of 2x plus 6 minus 5. Because 1/2 of 2x plus 6 is x plus 3. And x plus 3 minus 5 is going to give us x minus 2. And that's how I'm working in the inside derivative. All right, so now let's go ahead and rewrite the numerator. Okay, so there it is. And then I'm going to split this into two fractions because the reason why I went down this road is so that I can do a u substitution, right? U and du. But then what about the minus 5? Well, I'm going to have to split that integral. So I'm going to split that into 1/2 can go in the front. 2x plus 6 dx over x plus 3 squared plus 4. That would be the first part. The second part will be -5, the integral of -5 over that denominator. So I'm going to go ahead and proceed with my u substitution for the first part. And that would be 1/2 the integral of u, 1 over u du, right? Because this right here is du, and the denominator here is u, right? So 1 over u du, and the integral of that is 1/2 ln of absolute value of u plus some constant. Okay, now the second part of that integral, well, let's do another substitution. Well, I can't use u because I already used it. So let's say w. Let w be x plus 3. So this right here is my w. If w is x plus 3, and the reason why I do that is because I'm thinking inverse tangent. Something squared plus 1 on the denominator is going to give me inverse tangent. So then dw, in this case, is going to be 1 dx, which is great because that's what I have there. the negative 5 can be pulled in the front. So I'm going to write this in blue. The second integral, I'm going to write that in blue. So the negative 5 goes in the front, and then I will have 1 dw over w squared plus 4. But we know inverse tangent must have a square term and a plus 1, right? So what am I going to do? Factor out the 4. Factor out the 4. And when I factor out the 4, I will have w over 2 being my variable. So then the integral of that is inverse tangent. And then I would have minus 5 over 4 in the front as well. Okay, so yeah, so we finished. Plus some constant c, the second constant. So if we combine this part and this part together, substitute back our x's, we will get our final answer. So therefore, the final answer is 1/2 ln of u, which that is u right there, minus 5 over 4 inverse tangent of w, and that is of w over 2, and that is w over 2 right there, plus some constant c. And that is it.